Hi, good evening to all of you. Sorry for the delay. That was from my side. So, a very good evening to all of you. Am I audible at the same time? Do you see the screen as visible? Please let me know in the chat section first before we proceed. That will be better for us to start. Hello, Priyanka. Uh, we have, okay, I'm waiting for the responses from your side. The notebook. Come on, let me know first. Am I audible? Hmm. Uh, yes, voice is clear. At the same time, you can see me and I'm audible. Perfect. Good enough. Well, the Jupyter notebook is still starting. It's taking a lot of time today. Let's see. Just pull this out and I come back to this tab, closing this, closing my LinkedIn profile. Yes, sir, you're audible. Yes, thank you very much. Thank you, John. Thank you, Ankit, Dhruv. Prachi is saying I'm completely audible. Oh, thank you very much, Prachi. So, finally, the Jupyter notebook has opened. Okay, so LU Data Science Basics. I'll open this. We're going to create a new notebook today for NumPy. So first of all, let me just create it and then I'll start speaking on it. So copy this name, say okay, rename this to a new notebook which we are going to create. तो चलिए शुरू करते हैं. Wow. But I'm not technical Guruji. This is my NumPy module. So yes, how many people are we having? Okay, good amount of people. Let's get started with the session. Switch to dark mode, sir. Wow. But I will not switch to dark mode. Honestly speaking, yes. Jaya, I have tried the dark mode of the Jupyter notebook, but it's not working as expected. Okay, it doesn't work fine. Some of the things happen to be very good, but majority of the things, I'll tell you what exactly happens is this insert tab, cell tab, this run button somehow are not very much visible in this dark mode. And that is the reason I don't want to use the dark mode. Else I was very comfortable with that. I tried with a lot of different themes of Jupyter notebook, but unfortunately, no, none of them were better. So finally, I said that, okay, this is the best possible representation we can have. So let me just turn on my pen so that I can write it and show it to you. Oh, turn off the cam for better visibility. Ah, visibility would be better, but my communication will not be better in that case. So how many of you feel that turning off the camera is going to be useful? Okay. How many of you feel that turning off the camera would be useful? Just comment with yes or no. Should I turn off my camera? Yes or no. Should I turn off the camera? Yes or no. No. So I don't think so. Well, I'm sure the person who is saying this is definitely the one who is watching it from their mobile phone. And that is the reason you're feeling that. Else, I think the computer screen is sufficiently big enough to understand that. And yes, it gives kind of a more lovely experience to talk when you see me personally. And if I'm not there, I mean, you know how it is. Like you are just looking at the what do you call pretty dry screen on which something is happening and you have to understand. I think yes, this is kind of a very good communication platform by turning on the camera. Perfect. No. Okay, so let's get started. So we say चलिए शुरू करते हैं. So we have to start today with NumPy. So I'll just okay. Well, before I go to NumPy, let me tell you that today we are starting with the data science section. What all things are we going to cover in this section? Well, we have to cover the following things: NumPy, followed by pandas, followed by Matplotlib, followed by Cmon. Okay, so now, well, let me tell you, all of these are very powerful libraries for performing exploratory data analysis. Okay, each of this library is very much powerful for performing exploratory data analysis, and if you really want to explore each of these libraries, honestly speaking, there are so many functions and it's practically not possible to cover each and every function, but certainly we are going to touch upon some of the functions which I think are most important for you to understand. So I have selected few of the very important functions for you so that you can have a good idea as to how NumPy module is, Matplotlib, pandas and Cmon is. And to be honest enough, okay, let me be very honest that if you really want to learn all of this module into core depth, then that's exactly what we cover in our advanced program. All of these four modules, see, individually learning NumPy is 3 hours. Learning pandas is nowhere less than 3 to 4 hours. Matplotlib would be another 2 hours. Cbon is going to be another 2 hours. So you can understand that this is how deep the modules are. And after doing all those things, also, I don't say that the entire NumPy or Matplotlib or pandas or Cbon is getting covered. No, that's not like that. Even after that, there are too many functions available, but it is like once we start understanding what is NumPy, what is Matplotlib, and we understand few of the functions of it, our brain is tuned to go into the documentation and look for the appropriate function and try using it on our own. Because we have understood one thing, that Python is all about functions. It is function oriented. Everything is available. You just need to know how to pick up the things correctly. Okay, so luckily everything is available in Python. It's all about how do you customize it to your requirement. Okay, so you have to be intelligent enough in picking up the information correctly. So now, before I start, let me tell you few important points about NumPy. Okay, okay, even before I start, I think let us open the curriculum over here. Mm, yes, this is the one. mm, your Where is the curriculum gone? I think I skipped it above. Huh, yes, so as you can see over here, we are going to get introduced to what is NumPy array, what is 1D array, what is 2D array, and few functions of NumPy, followed by the slicing and the indexing operation in my NumPy. Okay, so now let's get started. So following are the things that we are going to cover in NumPy, and for today, the next thing that we will be covering is going to be the Matplotlib. So these are the two things that we are going to cover in today's session. Okay, so any questions? Okay, so today NumPy and Matplotlib, tomorrow pandas and Cbon. Okay, so I have kept this module open and this module open. Okay, so let me go ahead. Well, coming on to NumPy, I'll just clear this off. And what is exactly NumPy? Well, NumPy is one of the very important model. Well, let me tell you that NumPy is not the only thing. Okay, let me tell you over here that NumPy is not the only thing which is available. Okay, there are many other models available for performing. In fact, majority or not majority, but the operations of NumPy can be also done to some extent using our basic data structures like list, Python. So why NumPy? Well, the reason for NumPy is very, very fast as compared to Python's list or dictionary. Okay, as you compare with list and dictionary, NumPy is too fast. I mean, literally as good as 10 times faster than the Python's list, set, dictionary, and tuple. That's how powerful it is. And let me tell you, what is exactly NumPy over here? Well, NumPy says that num in NumPy stands for numerical, and pi over here, yes, you guessed it right, it is standing for Python. So when you say NumPy, it is numerical Python. And yes, it is first of all fast. I mean, it is almost 10 times fast than your traditional data structures. And it is also considered as one of the backbone of machine learning in Python. Yes. For understanding what is machine learning, well, it is one of the most important library. Okay. Now, well, the third important point over here is NumPy also adds support to core Python, because it supports for us multi-dimensional arrays, which we specifically called as matrices over here. Okay. Now, two important points about NumPy which you have to remember. Okay. The first is NumPy is specifically divided into two things. The first one, which we call are called as the or is called as the ND array. Well, ND array stands for n dimensional array, and the second one is called as the U functions. So precisely my entire NumPy is bifurcated into two types, ND array and U functions. And U functions are nothing but called as universal uh, functions. What is Rohit saying, sir? Really, Jupyter means Julia, Python, and R? No, 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 no. Of course not. Of course not. Jupyter doesn't mean Julia, Python, and R. Okay. There is no proper evidence which is saying that Jupyter means Julia, Python, and R. Okay. It could be, but I have at least not came across all of these things ever. Okay. So, well, let's go ahead now. Now, starting with the very first one, as I told you, NumPy. Well, okay. So, I was talking of ND array. Well, as I told you, let us get started. How to use NumPy? Hmm, let's see. Okay. So, we have to import NumPy. Just like we imported our math module, we need to import NumPy over here because NumPy is a package. Okay. And this particular package is available. And for using that, you need to say import NumPy. Yes, that's it. And you say enter. Okay. I happen to convert it to Markdown. That's my code cell now. So I say import NumPy. If I want to see the version of the NumPy, I just have to print over here. I have to print NumPy dot underscore underscore version underscore underscore. That's a pretty standard way for printing any library's version. If you import pandas or Matplotlib or Cbon, just by using dot underscore underscore dot version underscore underscore, you get the version of this NumPy. Well, NumPy comes installed in Anaconda by default, and that's exactly what you see over here. The version of NumPy which is available to me is called is nothing but 1.118.5. Well, NumPy is going to be like a library, and inside this library there are going to be many functions available. Well, I'll tell you, one of the function available over here is sum, one of the function available over here is mean, one is max. Well, these are very simple functions, but yes, they are available. And if you have to use any of these functions, you have to access it using dot operator. So you have to say numpy dot sum for accessing the sum function. Similarly, you have to say numpy dot mean for accessing the mean function, so on and so forth for all the functions. John, you need not install NumPy at all. If you are using Anaconda, the same software which I have suggested you, NumPy automatically comes installed inside that. Okay, so please don't write all those things in the chat section. we need not think of all those things. Okay, so now going further ahead, as I told you, there are so many functions, and today we are going to use a lot of functions of NumPy. And I cannot keep on writing NumPy dot, NumPy dot, NumPy dot, NumPy dot. So we can think of a shortcut over here. So I say that I'm going to give NumPy an alias name. Let me think of giving me it an alias name as NP. Okay, so this is what I have decided it to be given as an alias name. And how do we do that? Well, you just need to say over here import numpy as np, and it's done. Let me try to print the version. Now for printing the version, now I can always write np dot underscore underscore version underscore underscore, and let me tell you over here that this is again going to print the same thing, and from now I can use the alias name or the abbreviation for numpy as np. You can use any other word name, np or np1, or maybe your name, import numpy as darshan. Our aim was to reduce the code, and more of you can consider import numpy as np as a de facto standard. Okay, if you observe any reference book, any research paper, any Jupyter notebook which you see, everyone always imports numpy as np. So preferably you also get into the same habit rather than going offbeat. Okay. Okay. Hmm. It is Shubha Kumar is saying sometimes it doesn't go to next, it just goes to next cell. No, that never happens, Shubha Kumar. This never happens in Jupyter Notebook. Probably you are not pressing Shift Enter or Control Enter in the right way. Maybe you are pressing it in the wrong way. That is exactly why it is happening. Else it never happens. The software or the IDE is foolproof. It is robust. This will never happen. Okay. Statistics, are you covering, sir? No, absolutely not. And don't ask me all these questions. I just showed you the entire curriculum over here. I guess you have seen the curriculum. Everything is listed over here, and we are going to cover everything which is mentioned in the curriculum. Else, the subject is very vast. You know it correctly, right? So, yes. So now, no, it doesn't happen. It doesn't happen. I don't know. You are doing something wrong, but it will never happen that it will directly go to the next cell. No, it never happens. Okay. Okay. Let me go ahead. Now, let us start with creating a NumPy array. Well, how do you create a NumPy array? Well, I can create a NumPy array just by saying that, let's say ARR be my array, and create a NumPy array. I have a function, and that function is called as array function. It says, okay, says that if you want to create a NumPy array, you have to pass inside this a list. Okay, I have to pass in a list. So let's say I'm passing a list, maybe like 1, 5, 4, 2, 9. This is the list. Executed that. Let me print that. So you can see this is a NumPy array. And if you want to check the type of it, as usual, that doesn't change. RR. Okay. So you get it? Yes, it is a NumPy n-dimensional array. Perfect. Now, if I want to understand what is the data type of this, I just need to use the attribute ARR dot D type. Everything is now going to be ARR dot, because that is the array which we are talking of. As you can see, the data type is 32. So all of these values over here are converted into 32 format. Okay. Now let us try to do some changes over here. I say that I'm going to consider this array. Well, before I even go ahead, I say that np dot sum. Sum is a function, and I say I want the sum of ARR. If you observe the contents, 1 plus 5 plus 4 plus 2 plus 9 comes out to 21, and some function has helped us with that. np dot sum. Okay. Now let me create an array, and this time I'm giving this value not as 2, but I am giving this value as 2.0. Understand? I am giving this value as 2.0, not 2. Well, let's see what happens. So I say over here itself you print for me ARR, and over here itself you print for me ARR dot data type. D type stands for data type. Okay. So now the moment you do this particular thing, observe over here, earlier the data type was int32. Why was that happening? Because all the numbers which were stored earlier were integer values, 1, 5, 4, 2 and 9. Since all of these numbers are integer values, the data type turned out to be int32. Well, if we are using the Apple system, the data type can come out to in 64. Well, it doesn't make any difference. It comes out to in 32 or in 64. It simply means that in 32 is stored in a size of 32 bits, and in 64 means we are storing it in the size of 64 bits. So each number over here is given a size in the RAM of 32 bits. So 1, 2, 3, 4. In this way, there are 32 bits. And if you see the data type as in 64, each number is given a size of 64 bits. It doesn't make any difference for us. It is just for us to understand that yes, how it is stored. Similarly, if you observe, as far as Windows system is concerned, if I am giving a float value over here, observe the output very carefully. If any of the value turns out to be float, it converts everything into float. Yes. So now, if you see the data type is float 64, that means for storing this, it is storing it in total 64 bits of memory in the RAM. So of course, it is going to comparatively consume more amount of memory. Okay. Mohan, we need not install anything. Please attend the session right from the start. I answer all these questions on time. Everything was answered. Okay. Everything was answered. Okay. uh, I'm using Collab and it's in 64 and OS is Windows 8. That's perfectly fine. You don't need to care about whether it's in 32 or 64. It never bothers us. The only thing is over here that yes, it is of an integer data type, and if any of the value turns out to be a float, then it becomes a float data type. That is, it will automatically typecast all of the integer values to a float value. And you know why it happens? It happens because if you compare integer data type, well, this is how much an integer data type is going to be stored in, and this is exactly double. Float would be stored in this much type. So for storing any float, this is just an intuition for you to understand. Okay, so if one of the value is float, then all of the values would be converted to float. That's how NumPy does standardization. Okay, uh, that's fine. So if this is working fine, now let me try out the same thing. I say print for me arr dot sum. Oh, sorry, not arr, np dot sum, np dot sum of arr, and now you can see sum is still 21, but it is 21.0. Well, then the next question which comes is, can I have a NumPy array which has integer, float, and string as well? Yes, of course, you can certainly have NumPy array having integer, float, and string. But don't forget, what was the full form of NumPy? The full form of NumPy was numerical Python. Numerical, that means numbers. NumPy is designed to work best with numbers, not with strings. It would be kind of very silly enough of us if we are using NumPy for storing strings. Well, if you do over here, well, string requires much more space than a float, and not much more space, but string is stored in a Unicode character format, and that's exactly what you see over here. The data type of this is turning out to U32. U32 stands for Unicode character representation. Some of you can also get U11. That's perfectly fine. It is Unicode character representation. You need not get into the nitty-gritty details of that. They are nothing but the representations used by computer to store the data in the memory. Okay, so every character would be given some number. Like there is a representation I know which is ASCII number representation. People who are familiar to programming must remember it. So ASCII number system says that if you ask me to store a character A, in return in the memory I never store A, but I store a number called as 65. If a character B has to be stored, I store it as 66, so on and so forth for Z. If you ask me to store small a, I store 97, D is 98. Well, every character has a number code. So you mean to say that if it is a character like this, it also has a number code? Yes, it has a number code. I don't remember it. I have not memorized all these values. Is dot also having a number code? Yes, it does have it. Is a character like divide also has a number code? Star also has, and the answer to that is yes, yes, yes. Every character has a number code. Similarly, over here, this is one more type of representation which is called as Unicode. Well, having understood this much, this is more than sufficient. Okay, you need not know into the go into the nitty gritty details of what is Unicode representation, and if you really want to, you can always go into the Google and search out for Unicode character representation. Well, now you can see over here, this is the NumPy array, and since one of the data type is darshan, which is string, you can see all of the values inside this got converted to string, and therefore the data type is U32. Now if I try to find the sum of this particular NumPy array, I am a fool over here, because you cannot do all these things, right? How can you perform addition of strings? That's just not allowed. And always remember that NumPy is specifically designed for what? It is specifically designed for numerical computation. So better use it for numerical computations only. Okay, so that's exactly what we learn from this particular thing. Okay, now, mm, perfect. Let's go ahead. I am going to create a NumPy array now. So I say I want to create a two-dimensional NumPy array. So I say arr is equal to NumPy dot array. If I want to create a two-dimensional NumPy array, let me tell you how. I want to create an array 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the kind of array which I want to create over here. NumPy says yes, you can also create a 2D array. Well, if it was a 1D array, we all know that we just have to write 1, 2, 3, 4, 5, 6, 7, 8, 9. And the moment I say ARR, I get this, but we don't want to store it like that. Okay, so I say over here, ARR is equal to NumPy dot array, and I have to store it in the form of list of list. So I have created a list over here, and inside this, I'm going to give values 1, comma 2, comma 3. This is my first row. Then I give the second row, 4, comma 5, comma 6. That's my second row. Then I give my third row, 7, comma 8, comma 9. So if you observe over here, how have we specified it? We specified over here that this is my row number 1, this is my row number 2, and this is my row number 3. And this entire thing is specified in a list. So that's how easy it is to represent. Well, if I say I want to print it, let us see it. So I say print for me ARR, and that's exactly what we see. Well, let us confirm whether it is really a two-dimensional array. And to confirm whether it is a two-dimensional array, you just have to use the shape attribute. This is an attribute, not a function. If it was a function, then it would have had those round brackets. Just like we observed over here for this D type, right? D type is also an attribute. It is not a function. Sum is a function because sum has round brackets after this, but D type is an attribute. Similarly, over here, this is an attribute, and it says that yes, it is a NumPy array of 3 rows and 3 columns. Okay, so if it is a NumPy array of 3 rows and 3 columns, let me write it over here. It is a NumPy array of 3 rows and 3 columns. Okay, now if I just try out the same thing with my this one, so I need to specify over here print for me ARR, and then print for me ARR dot shape. Well, what do you think would be the shape of this? Just like I told you, this particular thing is having the shape as 3 comma 3. So what should be the shape of this cell number 15? What do you think should be the shape of this highlighted thing? Because you already see what is the output over here. So what should be your guess? What will be the shape of cell number 15? ARR dot shape. 1 cross 1, 1 cross 1, 1 cross 9, 1 rows, 9 columns, 1 cross 9, 1 comma 1, 3 stars 3 because array is you are going to see something surprising over here. If you observe, this is a 1D array. So we also see over here, there is just one row and 9 columns. So certainly we are expecting the output to be one row and 9 columns because it is always rows into columns. But if you execute this, what you see over here is NumPy doesn't store it as one rows and 9 columns. NumPy will say that this is a 1D array for me and I will only store the number of columns over there. 9 comma. Precisely, I should not even say their number of columns. It is like number of elements, comma. That is Raku. Okay, I don't know what's wrong, but things are fine. Just open this chat. Okay, perfect. Just confirm me. Show, am I audible now once again? Audible and visible?
Yes, sir, perfect.
Perfect. Why is my chat not getting loaded? I think there was some problem with YouTube because suddenly, all of a sudden, the chat also stopped. I'm just loading it. 434. Yes. Perfect. Let's get started then. Hmm. That is done. Where was I? Yes. So we understood that this is how the shape of the NumPy array can be thought of. Now let me think of one more NumPy array. I say over here, let's say I'm creating an array. I'll just copy paste this. Why to waste my time? So RR is equal to, and this time I say the third one is going to be, let's say 99 comma 45. That's it. And I print it. Well, if you observe, I am declaring a two-dimensional NumPy array, and if the values are not fitting as expected, that is, if you are expecting 1, 2, 3, 4, 5, 6, 99 and 45 over here, and you have not given this particular value, well, it doesn't give you an error, but it doesn't even store it as a 2D list. If you observe, how was it getting stored? If this value is there, this is how it should have been stored. But since the last value is not there, it is storing it as a list of list. Okay, and I can prove it to you by just printing the shape of it. So if I say arr.shape, and you can see over here the shape is 3 comma. Okay, so precisely it is telling us over here that there are total 1, 2, and 3 elements, or precisely there are 3 lists. So you never do such an operation. Either you make a proper 2D array or you make a proper 1D array. Don't do all this uncertain things over here. Okay, now, well, each of this operation has a significance. Today, you may wonder as to why this NumPy. I mean, we are okay. We are happy to see these functions. We are happy to see how it behaves. But where do we use it? Well, all of these models, NumPy, Pandas, Matplotlib, Seaborn, have been extensively used for EDA and machine learning stuff. So when you come to machine learning, when you come to understand those all things, at that time you start to respect these models a lot. So right now, it would be just like studying a different aspect of the programming language for data science, but the real-time applications of that would be very easily known when you go into the machine learning stuff of it. Okay, not even the EDA, the machine learning stuff. Perfect. So now, well, let's go to second function of NumPy. I say I'm going to declare an array, and if I say there is a function called as zeros, and if I say, what does this function say? This function says you have to specify it in the form of a tuple. So let's say if I give 2 comma 4 and I print over here ARR, well, it is going to create a matrix of zeros of 2 rows and 4 columns. That's exactly what you see over here, 2 rows, 4 columns. So I see over here, this is 2 rows and 4 columns. Well, that immediately brings me to the idea that just like I have zeros function, certainly I'll be having ones function as well. And yes, the answer to that is yes. It is for creating a matrix of all ones. So now let me proceed with the same idea again. So I say there is no function which is called as twos. We just have matrix of zeros and we just have matrix of ones. There is nothing called as matrix of twos. That doesn't exist. Okay, fine. So now there is one more function. Well, we all know that if I have a matrix like this is called as an identity matrix. How many rows and columns do you see over here? 3 rows and 3 columns. But one thing is sure over here, when it is identity matrix, we also know that identity matrix is always going to be a square matrix. If it is known that identity matrix is going to be a square matrix, NumPy says, okay, if you want to design it, how are you going to do it? Well, you just need to say over here, I'll write it directly, NumPy dot identity, and I need to specify over here 3 comma 3. Well, you get an error. That's not possible. You know why? It is because since it is always a square matrix, we know that identity matrix is always a square matrix. So why to specify 3 comma 3 and waste the memory? NumPy is very fast, I told you, right? And for it being very fast and it being very responsive to you, we always require the lesser number of variables to be used while computation. So it says that since it is going to be a square matrix, why are you specifying the rows and columns separately? Only specify one of it. That's more than sufficient for me. I will create an identity matrix for you. That's exactly what is happening in this case. Okay, one more thing. Inside NumPy, we also have a package which is called as random. So you might be wondering what? Well, just till now, I have been saying you that inside NumPy, you have few functions. And for using those functions, you have to just say import NumPy as NP, and NP.NP.NP. is the key to access all this. Well, inside this NumPy, it is a very huge package. Inside this, I also have one more module, okay? Inside NumPy, I have one more module, and that module is called as random. Okay. What are the dots? It is converted to float. 1 point is nothing but 1.0, 0.0, but since that value is not there, therefore there are dots. Okay, it will always see operations in NumPy are always done using float. Float is something which is very easy for calculations and very fast, and that is the reason it always converts everything to float in majority of the cases. If and only if the values in the entire array are integer, it will be considered as integer, else majority of the times it will be converting it into float format only. Okay, perfect. So now inside NumPy, we have a random package, and inside that we have few functions. Well, one of the function which I'm going to use right now is called as randn, which is standing for random number. How to use that? Well, we have already imported NumPy. So now I just have to say arr is equal to NumPy dot random dot rand n. See, so many functions are there inside random. So I'm using the rand n function. Okay, this function says me that I say that I want to make 3 comma 4 over here. So it specifies or it asks for me rows and columns. And if I say print, well, this is purely random. What I mean by that? Well, it is going to create a matrix of 3 rows and 4 columns, which is going to consist of pure random values. Now, many of the students ask that pure random values, so it can be any number. So the answer to that is no, it cannot be any number. Well, the numbers are going to be random, but yes, the numbers will always be centered around 0. Numbers will always be centered around 0. You observe all the values, they are as close to 0 as possible. For example, if I say I'll declare or take one more, I say over here, instead of 3 rows and 4 columns, I say I want 10 rows and 10 columns. And if I do it, well, once again, if you observe, aren't the numbers centered around 0, 10 rows and 10 columns? So if you observe all of these values, well, I see over here, all of these values are there and everything. I think the least value turns over here to be as less as minus 3.00, and the max value turns over here to be as greater as somewhere in the range of, I'm certainly sure it should be in the range of +3 only. So we just need to figure it out. I'm not finding the number 3 over here, but it has to be certainly in that range only as far as my experience. So I see over here +2.07 is there. But yes, the moral of the story is it is purely random. Okay, fine. So this is my random function. Many functions are available over here. We have just seen one of the function. I request you all to go through the other functions as well. Now we are going to the next thing, which is my indexing in Numpy. I'm going to create an array np dot array. So let it be a 2D array over here. So I say 1 2 3 comma 4 5 6 comma 7 8 and 9, 8 comma 9. Okay, let me print it. We know how it is going to be printed, but let me print it over here because we are going to require it multiple number of times now. Np dot array. Oh, it has to be a list of list. List of list is specified. So I say, how is this going to be stored? So it is going to be stored like this: 1 2 3 4 5 6 7 8 9. Precisely, we know that this is going to be a list. This is going to be a list. This is going to be a list, and overall this is going to be a list. Well, let me tell you how the indexes are being assigned. Well, it says that this entire thing is my 0th row, this entire thing is my first row, and this is my second row. And inside that, this is my 0th column, this is my first column, and this is my second column. 0 1 2 0 1 2. Okay, so if this is how the thing is, let us see. If I say over here, or if I come down, since this is already there, if I say what is going to be arr dot shape, well, we know it is going to be 3 comma 3. Now if I say what is arr of 0, you can see over here arr of 0 is this entire row, which is 1 2 and 3. Similarly, if I say what is going to be arr of, let's say, 2, that is going to be 7 8 and 9. And if I have to access, okay, if I have to access, let's say, a particular column as well, you just need to specify over here arr of 0 followed by arr of 1. So this is going to access 0th row first column. So the 0th row first column is nothing but 2, and you get over here the output as 2 as well. Okay, now I will also like to show you over here one more function. Well, if you remember, we happen to cover the range function in list. And if I say range of 5, if I say range of 5, it was generating numbers from 0 to 4. Here, I am also going to use my range function over here. So I am saying over here that print for me range of 12. We know that it doesn't print anything, but NumPy says I also have the same function which is called as range function, but it is far much better, far much faster. And for you to use that, well, that is available with me. So you have to write np, and the name of the function is not range. NumPy calls it by a different name which is called as arange. However, the entire working is the same. So I say over here np dot a range of 12. The moment I say np dot a range of 12, it is going to generate 0 to 11 values. This was not happening in case of range function. Range function has to be used with a for loop. NumPy says it can be used directly. Okay, now I say let me store it, or rather I'll say over here I'm using a function after this which is called as reshape function, and I say that it is going to consist of 3 comma 4. Well, what do you understand by that? What we understand is if I execute this cell, What do you see over here? It says that the values which is np.a range of 12, we all know what values has it generated. It has generated the following values: 0, 1, 2, 3, 4, right up to 11. I say rearrange these values in 3 rows and 4 columns. Okay, so we have to assign 3 rows and we have to assign 4 columns. And now just start filling in the value. The values are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, they would be filled in left to right, top to bottom fashion. Okay, so this is exactly what we see over here. Revamp it into 2 rows and 3 columns. Well, I can also think of storing 2D arrays into a numpy. Okay, so I can say over here, observe over here. If this is clear, I'm going to do a very interesting thing later on. But right now, this thing, okay, this thing, what you see over here, the multiplication of this value should always be equal to this. Then only reshape is possible. Okay, if I say 3 into 4 is equal to 12, then only reshape is possible. For example, if I say over here, reshape it into, I'll just take it down so that you have a lot of examples for practice. If I say I want it to be made into 4 cross 4, well, 4 cross 4 is 16. And how many values do I have? Just 12. Cannot reshape array of size 12 into shape 4 by 4. So can I do it into 4 by 3? Yes, of course. Same values: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 4 by 3 is also allowed. Similarly, can I say it can be 6 rows and 2 columns? Of course, if 6 into 2 is equal to 12, then this is certainly allowed. Similarly, I can also say over here 2 rows and 6 columns. Every factor of 12 is very much allowed over here. So we understood that yes, this is how my range function is going to use. Now, one more thing which I want you to understand. We understood the range function, we understood the reshape function. There is one very interesting thing of reshape function, and that interesting thing is, well, I can say over here dot reshape and 2 comma 2 comma 3. You know what I mean over here? I am saying over here, sorry, 2 comma 2 comma 3. Why this happened? 2 comma 2 comma 3. I say over here that I want to create total 2 arrays, and each array should be of dimension 2 cross 3. So first array would be of dimension 2 cross 3, second array would be of dimension 2 cross 3. Well, if you calculate using mathematics, this turns out to be 6 values, this turns out to be 6 values, and 6 values over here and 6 values over here exactly account to 12 values. Or you can also say 2 into 2 into 3, 2 2s are 4, 4 3s are 12, it is equal to this. Same thing. So what happens in this case? Well, I am saying that I want you to rearrange the following thing into 2 arrays, okay? And each should be of 2 rows and 3 columns. So this is my 2 rows and 3 columns. This is my 2 rows and 3 columns. I'll just put a dash over here. So 2 rows, 1, 2, 3. Okay. And it says reshape it. And these are the values. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, if this is what is going to be stored, we have to certainly understand how is my indexing operation going to work over here. So my dear friends, this array is being stored over here something like this. And let me tell you overall, this thing, okay, this entire thing is called as the 0th array. This entire thing is called as the first array. If I just talk of the 0th array, this is called as the 0th row, this is called as the first row, this is called as the 0th first and the second column. And similarly, if I talk only of the first array, this is called as the 0th row and first row. This is my 0th first and second column. Why are we doing this? because now we have to understand the working of this in more detail. So what more detail about it? Well, let's move on to indexing operation over here. So first of all, I'm sure you are convinced with what we have drawn over here and what we see over here. It's exactly the same thing over here. Now, the best part of it is if I say what is ARR of 0. Oh, I did not save it. My bad. Store it into ARR. And oh, I need to print that. How will you be able to see that? Okay, so it's the same thing. Mm, uh, okay, what has this come over here? Oh, okay. Now, if I say print for me ARR of 0, that means I have to print the 0th array. Observe over here, the entire 0th array, which is 0, 1, 2, 3, 4, 5, which you can see from here also, that gets printed. Certainly, that brings us to the conclusion that ARR of 1 is going to print for us the lower array, obviously. Fine. Now, if I say ARR of 0 followed by 1. So that means go inside the 0th array, and inside the 0th array, I am talking of the first row, that is 3, 4, 5. Well, if you observe, that's exactly what you get. So if this line is going to give me 3, 4, 5, inside this, where is 5 located? 5 is located at index location 2. 3 is at 0, 4 is at 1, and 5 is at 2. So what I do is I'll just copy this code and write over here. So that gives me 5. Well, if you have understood this, you have to tell me that I want to print 7. So what should I write over here? ARR followed by square bracket x square bracket y square bracket z. So my question to you is, if I want to print 7, what should be the values of x, y, and z? What values do I need to substitute for x, y, and z? The entire diagram is available over here. I have to substitute 7. Let me see how many of you can understand this thing. Okay, I'm expecting an answer from all of you guys. One zero one 101 101, and not even a single person has given his right. Perfect. So hopefully that is correct. This is 1, this is 0, and this is 1. And yes, it has given us the same answer. That's really nice. That's really nice. Okay, so now that we have understood this, one last thing which I would like to show you over here is slicing operation. Okay, since this is clear, now we have to go on to the slicing operation. Well, if I say what is going to be ARR of, let's say, 0, ARR of, let's say, colon, I say 0. Okay, 0 colon, or rather let me take a 0 colon 1. That means I want you to slice from array 0 to array 1 minus 0, because end index is always end index minus 1. So it has given me 0th array. Similarly, I say I want to slice from 0 to 2, is going to give me array from index location 0 to index location 2 minus 1. Well, similarly, if I say np dot a range of 12, we know what is a range of 12 is going to do. Well, inside this, let us say that if I specifically want to slice out values from here till here. Where are these index locations? This is our index location 0, 1, 2, 3, 4, 5. So I will have to specify starting index as this and ending index as this, so that it will be fetching everything from here to here. So 1:6 should help me out. So now observe, I can say over here, okay, Control A, Control C, I specify over here and I write 1:6. Yes, I can write it exactly ahead of it. No one is going to stop me. Python says you can go any level ahead of it. So this is the output, okay? And if I take this once again, and if I say inside that specifically, I want, let's say the number called as 2. 2 is present at index location 1. So I specify over here 1 and I get the number as 2. Well, after that also, if I want to perform some operation, if I want to check the type of it, so I can always say type of this entire thing which I copied. Okay, obviously it has to be 1 over here. That is going to be int 32. Okay, so many things can be done on the same using function composition. Perfect. So now that we have understood one basic part of it, I like to show you few more operations. Well, what is this? The next one which I want to show you over here is few array operations of NumPy. So I say over here, let's say if I have a NumPy array, so I say np dot, or not a range of, let's say, 15 dot reshape of 3 rows and 5 columns. Okay, that's fine. Okay, we have this. Now we all know that if I want to add something to this array, if I want to add two arrays as per the rule of matrix multiplication, if I have a array like 1, 2, 3, 4, and if I wanted to add with some other array, it has to be of the same dimension. Okay, so if this is of 2 cross 2, this also has to be of 2 cross 2, then only our answer would be 2 cross 2. That is, in this case, 2 plus 1 3, 2 plus 1 3, 3 plus 3 is 6, and 4 plus 7 over here is 11. Then only you get it. But as far as NumPy is concerned, NumPy says that I have a fantastic thing with me, and you know what is that called as? That is called as ufuncs. We just understood it right at the start of the session that NumPy is divided into two parts. First is ND array, which we just saw, and the next is U function, that is universal functions. Well, the advantage of universal function is they allow us to achieve the facility of broadcasting. Yes, I can achieve the facility of broadcasting. So if you observe over here, if I say this is what my ARR is looking like, if I say I want to add 5 to this, it will not give an error. Instead, 5 number will be added to every value in the array. You can observe every number in this array has been incremented by 5. That's exactly what is the advantage of this. Very interesting. Similarly, you can also say ARR multiplied by 2. Yes, that is also certainly allowed. Every number of the array is multiplied by 2. Now, I'd like to show you one more operation over here. So, let us say I have over here one array. I'm going to call this as array 1, and I say np dot range of 15 dot reshape of 5 rows and 3 columns. So we know how it is going to be created. I create array 2 by saying np dot range of, let's say, 5 dot reshape of 5 rows and 1 column. Let me print that out first to confirm whether they are perfect. So this is my array 1, and this is just a blank statement, and I say array 2. Yes. So now if you observe, the first one is saying that this is a matrix of 5 rows and 3 columns. The second one is saying that this is a matrix of 2, 3, 5 rows and 1 column. Well, certainly we know as per the rule of mathematics, these two arrays cannot be added, right? But NumPy says I can do it. Well, how? NumPy says, what is the array that you are talking of? 0, 1, 2, 3, 4. So you basically want to add this array with this array. Well, this array, this is 5 rows 1 columns and this is 5 rows 3 columns. So NumPy says I have a facility of broadcasting using U functions. I will replicate this once, I will replicate this twice, and now I can very well say that this 5 cross 1 has been converted to 5 cross 3. And now when you perform the addition of that, what is the expected answer? 0 plus 0 would be 0, 1 plus 0 would be 1, 2 plus 0 would be 2. Then over here every value is going to be added with 1. So 3 is going to become 4, 5, 6. Next it is going to become 8, 9, 10. Next it is going to become 12, 13, 14. And lastly 12 plus 4 is 16, 17, 18. So this is the output of 5 rows and 3 columns. And yes, NumPy is going to support this, a very interesting feature. Now you may say that, okay, we are fine, okay, we are convinced, okay, these all things are happening, but what is the use of that? Well, the use of this will be clear when you go into the deep learning stuff, not right now. Okay, not right now, but when you enter deep learning you will realize that yes, this feature is very important, because that's how you have to change your images in the matrix. Okay, your images are always represented in the form of matrix, and when you come into deep learning you have to always keep on transforming the images, rotating the images, or finding the transpose of the image, or sometimes rotate the image in 90-degree direction. All these things are very important over there. So if I say over here that I want you to print ARR1 plus ARR2, well, this is the answer which is expected. Let us see, scroll it and compare this with what we have solved. That's exactly as expected. Perfect. So yes, now let's go down. Well, I can also perform my linear algebra on NumPy. What do I mean by that? Well, if I have a NumPy array, maybe I say I have a NumPy array np dot array, and I'm going to create a 2D array 1, 2, 3, comma, let us say 4, 5, 6, comma 7, 8, 9. I'm going to create one more. B is equal to numpy dot array, and inside that I'm going to create oh, I'm sorry, my bad, I always forget that that has to be a list of list. I say let that be 2, 2, 2, just for simplicity purpose, 3, 3, 3, comma 4, 4, 4. That's just for simplicity purpose. I am just assuming few of the values. Now I say over here, print for me A, print for me B. Let us leave some space. So I say over here print. Okay, these are the two matrices. Now I can perform matrix multiplication using the dot function. How? Well, you just have to say A, the function's name is dot B. Okay. Now A dot B is going to perform the multiplication. As you can see, this is 3 cross 3, this is 3 cross 3, therefore the output is also 3 cross 3. Of course, we don't have time for confirming the matrix multiplication, but it is 100% correct. Okay. Now, the next one is, well, if I have an array over here, let us say I'm considering this array itself, and I want to print this array. That's how it is. I can also calculate the transpose of this array, and calculating of the transpose is not even a function. You just have to write dot and you get the transpose of this array. And you can see over here 1 2 3 has become column, 4 5 6 has become second column, and 7 8 9 has become the third column over here. So okay, so dot is a function used for matrix multiplication. Dot is a function. And what is this dot? Well, this dot is what you always do, right? Numpy dot, numpy dot, and the function's name over here dot. And we say, I'll just document it over here for you. I say dot function does perform matrix multiplication. Clear? Great. Now I can also perform linear algebra. Okay, I can perform linear algebra using NumPy. Now the question is how? Well, let us say I have few equations to be solved. Okay, and the equation is something like this: 3x minus 5y plus 2z equal to, let us say, minus 8. There's one more which I say 7x plus 5y minus 3z equal to 16. And one last, let's say 5x plus 3y minus 7z is equal to 0. Well, we all have solved this in our school level, how to solve this equation to find the values of x, y, and z. Okay, this equation can be consisting of more number of values as well. It can be x, y, z, a, b, c also. Let us solve it for 3. NumPy says I have a package, I have a sub package which is called as linear algebra, which can do this for me. For example, NumPy says you want to solve it, so you do one thing: all the LHS of this equation, that is these values, and these values, give it to me. So I say okay, take it. I am giving it to you over here in the form of a NumPy array. So I say NumPy dot array. Oh, NumPy dot array. And what are the values? 7 5 and minus 3, right? I have to substitute these values: 7 5 minus 3, 3 minus 5 2, and this. Okay, so I say okay. So the first value over here in the form of a list is 7 comma 5 comma minus 3. Okay, then the next is 3 minus 5 2, 3 comma minus 5 comma 2, and the third one is 5 3 minus 7, 5 comma 3 comma minus 7. Okay, so that's my A, that's done. In B, you are going to do the same thing, but you will be storing all of the RHS part over here in B. So I say over here, okay, so my B is going to be is equal to numpy dot array, and we say over here what are the values. Well, it is a 1D vector, so I need not write list of list. It is 16 minus 8 and 0. Okay, so having done that, now I say over here I have to solve it. Look how simple it is to solve. I just need to say over here that my answers, I'm just using a variable name as answers, are going to be is equal to, there is a function of numpy which is available in the linear algebra. Okay, linear algebra, LINALG, and the name of the function over here is, as the name says, solve. What do I have to solve? A and B. That's exactly what I have supplied, and all of my answers are available over here. So I simply print it, and well, my dear friends, what you see over here, this is the value for x, this is the value for y, and this is the value for z. Solving these three equations, NumPy has done this so easily for us. How much time do we take for solving it? Definitely much larger than this. And this is only with three variables x, y, z. Even if you happen to give it more variables, then also it will be able to solve it. For example, screen is not working. No, I don't think so. If screen is not working, then many people would have commented the same thing. Okay, so perfect. Let us try using more number of variables over here. So I say paste it. Let us say I'm going to give, let's say, around 10 variables. So comma 55, comma 4, comma 66, comma 77, comma how many values are given? 1, 2, 3, 4, 5, 6, 7, 8, comma 9, comma 10. So I need to give 10 values over here also. Let me randomly pick up these values so that I need not waste time in typing this. So 3 are done, and 4, 5, 6, 7, 8, 9, and 10. Similarly over here, I'll specify comma 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, 10, 10, 10 values. Solving over here, obviously there are going to be 10 values, so I don't know whether it is going to work, but let us say it is adding or subtracting. What kind of question is this? It is not adding or subtracting, it is solving the linear equations. Let me say this is my RHS 1, 2, 3, 4, 5, 6, 7, 8, comma 9, comma 10. Last two dimensions must be square. Last two dimensions must be square. Oh, they are not square. Of course, yes, they have to be square, right? It should be 3 and 3. Okay, okay, okay. So I messed up. Last two dimensions must certainly be square. So this plus this should not be equal to this. Oh, okay. So let's not try this. You can try it later on with all other combinations. Okay. So now let's go ahead. After this, of course, you have some other functions as well. I can now move on to Matplotlib. Okay, we can now move on to Matplotlib. Okay, let's get started. So I say over here,
Sir,
yes.
can we give the attendance form before we start Matplotlib?
If you think it's the right time, we can.
Okay, we'll just give the attendance form.
Okay, no problem, no problem. Sure, we can do it. You're doing it, na?
Guys, I've put the attendance link in the description. Please fill the attendance form.
The form is perfect, guys. It's opening in my mobile. Don't say it's not opening. It's perfectly opening. Are we going to use any data sets? Yes, but data sets are not used in NumPy. They are used in Pandas. So that will be covered in the next session. You have missed your day one attendance, then I'm sorry, I don't know what can be done. You can talk to the Let's Upgrade team, but please don't be that much careless, guys. No, it's opening, but it is showing day one. Absolutely not. It is showing batch one, day three. It is showing perfectly. No, the private speaker, it's showing it correctly. Mahesh, yes, we are going to use the data sets, but that comes in Pandas. NumPy is not about using the data sets. It's about numerical computations. So it is also saying. What is the status, Shoaib?
Yes, sir. We have got enough attendance. We can move on.
Okay. Okay. See, the form is perfectly loading. I also tried it. So you can see the form is loading perfectly. Day three attendance, that's also clearly mentioned. So I don't know why are you getting all these things. Okay. So let's go ahead. Let's get started with Matplotlib now so that for tomorrow we have Seaborn and Pandas. So getting started with Matplotlib. Well, uh, first of all, well, let me tell you a few points about Matplotlib. Well, Matplotlib is first and foremost used for visualizing the data. So whenever you think of plotting it with the help of some graphs or with the help of some plots, you go to Matplotlib. And let me tell you that Matplotlib is built over our NumPy, and that is the reason we are studying it coupled with NumPy. Again, it's a very huge library. Okay, so coming over here, one of the best part of the Matplotlib over here is it can be capable to be working with majority of the operating systems without any problem. That is one of the key strengths of Matplotlib. First of all, I'll tell you that Matplotlib, why was it written? Earlier, there was a software which is called as MATLAB. Has anyone used MATLAB previously? Any one of you have heard of MATLAB or used MATLAB software previously? Yes, probably what usually computer students and electronics and telecommunication students may have used that. Okay. Yes. So yes, MATLAB is a software which is used by those students. And precisely the most important advantage of MATLAB is that it can do image processing applications, and it can do those things really very easily. So now if Matplotlib was easy, the coding of Matplotlib was as easy as Python. In fact, Python was inspired from MATLAB. So if MATLAB is already there, why this Matplotlib came in Python? Well, MATLAB used a programming language which is called as MATLAB only. Okay, MATLAB programming language. But the reason for Matplotlib to come into picture and it shine it to shine as compared to MATLAB is because MATLAB is paid. If you are using it, you have to buy a licensed version of it, just like you buy for your Windows operating system or any other operating system. However, Python is open source. Since Python is open source, that is the advantage, and therefore many people are learning Python. So as I told you, Matplotlib was actually built as an alternative for MATLAB. And honestly speaking, in recent years, Matplotlib is something which has started becoming obsolete. Okay, the features of Matplotlib have started becoming obsolete, and very strong libraries like Seaborn, like ggplot, or we say there is one more which is called as d3js or html canvas. All of these libraries have started coming into the picture, and Matplotlib have started showing its age. But still, it is very important to always start with ABC. So anyone today, any data scientist, if you ask, none of them say that we don't know Matplotlib. You have to certainly understand Matplotlib to go into understanding the higher libraries like Seaborn. Well, this is another library which is very powerful and very interesting, which is called a ggplot. Okay. Apart from that, yes, there is one more library which we cover in our advanced data science course, which is called as Plotly library, which is based over JavaScript. Okay, that is again a very powerful library. So let's get started with this then. So coming on to Matplotlib, how to use it? Well, you just have to say import matplotlib dot subpackage pyplot as plt. Now you know it very well, right? And I need to set the styles. What is that? I'll tell you. See, we have to understand over here, whenever it comes to visualization, it is all about what feels pleasing to your eye. I have a car whose color is red because I like red. Earlier, I had a car which was blue because I like those colors, but I don't like gray color. I never purchase a car of that color. So there could be some people who like gray color. There could be some people who like white color, golden color, yellow color, what not. So it's all about what feels pleasing to your eye. You set that particular color. Similarly, over here also we have themes. Just like in mobile phone, we set different themes so that we get a change over here. Matplotlib also says that I have various types of themes available. One of the theme that I'm going to use now is called as classic theme. I will show you what all are the different themes. But the first thing is we are going to use the classic theme. And for that, I say over here, I'm going to set the style. How? I say lt dot style use, and I say over here classic. Done. So what are the different styles available? Well, I'll just like to go over here and show it to you. Mm, mm, Matplotlib styles. Let's visit this link. Oh, so which one are we using? By the way, we are using the classic one. So I come over here, and well, all of these charts, chart number 1, chart number 2, and chart number 3, everything is showing the same diagram. Okay, but BMH, they look certainly something like this. This is how my BMH looks like. The same diagram in classic looks like this. One of you demanded let's go for a dark theme. They will look like this in dark theme. Just like this, you have some other, as you can see, few more themes. 538. The same graph should look like this. ggplot. So whatever feels appealing to your eye, this is for grayscale, this is seaborn bright, whatever you feel good to your eye, you can start using it. Similarly, we have seaborn color blind, we have seaborn dark theme, as you can see over here. This is seaborn dark palette. Following are the three things. You can use anything. Few more themes, as you can see, right up to next one, next one, next one. So many themes. Seaborn white is the second last one, and the last one is the seaborn white grid. So you understand that you can use any of the themes of your size, of your choice. I'll just paste this link for you so that you can try experimenting with all of this. So we are done. By default is also classic. Just verify it. I don't know. I usually have a habit of doing it, but I think by default it's classic only. Perfect. Now I'm going to use my numpy's function, one more numpy's function, which is called as line space. Okay. So okay. So that is called as line space. So I say over here, x is equal to numpy dot line space. What is this going to do? If I say 0, comma 10, comma 5, it is going to generate 5 numbers which are equally spaced between 0 and 10. I'll show you how. If you observe over here, it has generated 5 numbers which are equally spaced: 0 to 0 0.5, 2.5 to 5, 5 to 7.5, and 7.5 to 10. 5 numbers equally spaced at a gap of 2.5. Okay, so of course, now I say that since I understand this, I'm going to say 0, comma 10, comma 100 such values. Oh, we know how it works, so I need not worry about it. And then I say I'm going to use my plot function directly. How do I use it? Well, we have imported Matplotlib as PLT, and I say over here PLT dot plot. Now this plot function takes with me two values. What is on the x-axis? What is on y-axis? So I say on the x-axis, I want you to plot x. On the y-axis, I want you to plot the sine of x. How do I do that? That's available in NumPy's sine function. So I say plot for me sine of x versus sine of x. I'll just hide this because we require a bigger area, and I'm going to reduce the font now. Okay, very soon I'm going to reduce the font because the charts will not be accommodated. So you see over here, okay, what do we see over here? So we clearly see on the x-axis, this is my x, and over here I have my sine of x, and obviously we know this is how the sine wave looks like. So these are 100 numbers which are equally spaced. That's exactly what we have generated over here. Similarly, I say like to add one more thing, and I say plt dot x versus np dot cos of x. Now, did you see Matplot was intelligent enough to choose the different colors automatically? The first one was by default blue, and the second one, as you can see, right? So, but there is one thing which we don't like, this thing. What is this? This is saying that this particular figure is stored in the RAM at address 0x blah blah blah. If you don't want to see this, if you think that it is making the things ugly, just ensure that you put a semicolon at the end. It is going to suppress that. If I execute it now, it will just suppress that object. You see only the chart over here. Okay, so that's the advantage of this. Now, I would like to tell you that there are two modes in Matplotlib. The first one is, I'll show you, which is called as Matplotlib Notebook. Matplotlib Notebook. Not Notebook, it's just Notebook. And Notebook also works. So I'm going to take the same code, absolutely same code. I say Matplotlib Notebook and I paste the same code. Now observe, only because of this line, what is going to happen? Okay, that's exactly what we are trying to see. Well, when I did not had this highlighted line Matplotlib Notebook, what you see over here is a chart which is pretty static in nature. I mean, I cannot do anything with this chart. Even if I try to pull this around or I try to zoom it, nothing happens. But the moment I say Matplotlib Notebook, it gets for me a very interactive chart. You want to see that? I'll just execute that for you. So I do that. I'll just reduce the size. I have to further reduce. Okay. So you see over here, this chart has become much more interactive now. I can think of zooming. So I can just scroll over here. I can scroll over here. I can scroll a bit up. I can scroll a bit down. Well, as you can see, this is what is available. Then this particular option is this. I can also zoom this rectangle. I can see a better view. Okay. And then by scrolling over here, okay, by activating this, by scrolling over here, I can also see the value at this point. What is the value of X and what is the value of Y? Similarly, over here, I can see the value of X and Y. Where I'm looking over here, okay, observe over here when I hover. So when I hover over here, observe where I did show you just now, loom rect X is equal to this and Y is equal to this. So all of these values on the plots are visible. So it has become interactive. And they say we can also store it. So once I clicked on that, it actually redirected me over here. Nothing happened, but I'll just check it once again. Nothing happened. Let me see whether it has stored it or not. No, not now, but it can. Uh, and if I want to restore back, I just press this button. It's a normal chart now. Okay. So what is the next mode? Okay, this is fine. This mode is understood to all of us. The next mode that we have over here is my Matplotlib inline. Well, let me tell you, this is the default mode. If you observe, uh, unrecognized argument and Matplotlib. Oh, that should be because of this. I did not stop it. That could be the reason. Okay, it has to go on the next line. No problem. Well, this is the basic chart. We always go with this only unless and until you want to stretch and see all those things. Okay, so Matplotlib inline and Matplotlib notebook. By default, it is always inline only. Okay, now I can also show you few more things over here. I go down and I say Let me have the same thing. I just write over here comma. In single quotes, I put a dash. Dash over here means a solid line. And over here in single quotes, I put dash dash. And dash dash over here means a dashed line. So if you observe over here, when I execute it, well, you can distinguish between the two lines. Okay. By having dash and dash dash, you can certainly distinguish between the two lines. Now, are you able to get this? Okay, I'm just looking into the chat. Sometimes some weird things I do see in the chat. I mean, why is this COVID and all coming over here? Quite surprising. Okay, so I was saying over here that this is how we plot it. Now, what are we going to do is, well, I see over here that this is my first thing, which is called a sine wave, and this is my cos wave. I don't want it like that. Okay, I want my sine wave to be plotted over here, maybe something like this. And exactly below that, I want my cos wave to be plotted, maybe something like this. Okay. So it is going to be a single page only, single graph only, but this graph will now be divided into two parts. Okay. So I'll just write it. I'll just show it to you and clear this out. Hmm. Okay. So what am I going to do over here? Well, just like you used to do in your class, you used to ask your teacher whenever you're giving an exam that I need a graph paper or I need a plot. I say the same thing over here. How? I say I request it by using plt dot figure. That's it. The moment I read plt dot figure, I'm requesting for a graph paper from my invigilator. And then I say plt dot, just clear this out, subplot 2 comma 1 comma 1. Well, what happens over here? Understand this thing. 2 comma 1 comma 1, it basically says that I want you to create, the moment you have borrowed a graph paper from your teacher. Well, that's exactly what your line number 1 has given. Line number 2 says you are going to divide this graph paper into 2 rows and 1 columns. You are going to divide it into 2 rows and 1 column. So here becomes my 2 rows and 1 columns. So okay, that's fine. So this is going to be my first row. This is going to be my first row, or rather I will say this is going to be my first subplot, and this is going to be my second row, or I would say this is going to be my second subplot. Okay, so how do I say over here? So I say that I want you to create a subplot of 2 rows and 1 column, and currently I am talking of the first subplot. Currently I am talking of the first plot. So I say over here, how do I do it? Well, I just need to specify what I want to do over here. For example, just a second, I say lt dot plot, I say x versus np dot sine of x, and let's say we want it to be a dashed line. Well, if I execute this, you don't see as expected, but certainly the size of the figure has reduced. Now what do I do? Now I say plt dot subplot 2 rows 1 column, and currently I am talking of the second part of it, that is I want you to plot it over here. And what is that going to be? I say plt dot plot, I say 2 rows, or no, not 2 rows, x versus np dot cos of x, and that's going to be dash dash. I just want to put a semicolon so that this object which is getting printed can be suppressed. So I do see over here the things as expected. So I can divide it into literally any number of subplots I wish to. Okay. Now the next thing is, since this is done, next thing which I will like to show it to you is, I say labeling the plots. Okay, last 2 3 things over here. Labeling the plots. Let's say I have plotted over here using plt dot subplot, and I say not subplot but plt dot plot x versus sine of x. That's fine, and we know how it looks like. This is how the chart is going to look like. Then I say, if I want to give a title to this plot, I just have to say plt dot title and say it is nothing but a sine curve. The moment I execute that, you can see over here at the top the name came up, a sine curve. This is the title of the plot. Okay, interesting. Similarly, I'll just do it over here. Then I say plt dot. I want to also label the x-axis and the y-axis. My x-axis and y-axis should now be labeled. So I say over here plt dot label, and that is going to be my simple x. And similarly, I say plt dot y label, and that's going to be my, not y, it is going to be sine of x. Put a semicolon over here, and you can see over here sine of x came over here and x came over here. Okay, I see something very interesting in the chat. Well, it is something which is by default understood, but it's okay. Someone is saying that what if I want it, let's say this graph paper to be divided into this. Well, again, the things are very simple. I say I want it to be divided into 1 rows and 2 columns. Rest everything remains the same. So if I just take advantage of the same thing and I add a cell after this, what I have to do over here is I have to specify that I want to divide it into 1 rows and 2 columns, and currently I am talking of the first part of it, and this is the second part. So that's exactly what we do over here. So I say, if this is the case, once again I say 1 comma 2, and that's exactly what you see. Now, yes, I can see the figure is a bit compressed. I can give a dimension over here, which is called as fixed size. Well, you can think of this as pixels, or you can think of it as inches of the screen, 10 rows and 8 columns. We can see over here it has stretched. Okay, 8 is, I think 8 inches is too big. I will just get it down to 5. That also seems to be a bit stretched. I think 3 would be a good one. Okay, that's better. So I can use the fixed size as the dimension over there. That's perfectly fine. Okay, so that is one thing. Some people say, what if I want to divide it into 4 parts? Well, the same thing is going to happen over here. Okay, if you want it to be divided, let's say into this particular thing, then what are you going to do? Again, copy paste the same thing over here. State, I say I want it to be divided into 2 rows and 2 columns. So this is 2 rows and 2 columns. So this would be the first plot, this would be the second, this would be the third, and this would be the fourth. So let's say 2 2 1. This is going to be 2 2 2, and this is going to be after that. Let us say copy this so that we can reuse it. Paste it. That is going to be 2 comma 2 comma 3. This is going to be 2 comma 2 comma 4. Let this be not cos of x, but let this be a sine of x and a cos of x. A sine is cos is not working, so I guess it should be sine hyperbolic then. So sine h, hope so it works. Sine hyperbolic works, so I can go over here for cos hyperbolic as well. And yes, so you see over here, this is how the plots are going to be. So yes, very interesting, right? Okay. Now, yes, as far as color changing and all are done, a lot of things are possible. But of course, due to time constraint, as I told you, each module is a big module. Covering everything over here certainly is not possible. Okay. So one last thing which I would like to tell you over here is, if I want to give labels, how can I do it? Well, I happen to give over here X label, Y label. I want to give the legends now, legend. How do I do it? Well, I have to just specify over here. Well, let me do it in a separate cell now. I say plt dot plot, and that's going to be x versus np dot sign of x. Okay. I'll just show you the color part also over here. If I specify over here dash G, that means I want a solid line. Dash means solid line and G means green color. Okay, there are multiple ways of setting it. This is one possible way. So I'm saying that I want this X versus sign of X to be a solid line of green color. Okay, let us see. So as you can see over here, solid line of green color is there. I say over here, I want to do one more thing, and that is going to be my label. My label is going to be over here nothing but my sign of x. Similarly, I say plt.plot, and I say that's going to be x versus numpy dot cos of x over here, and I say over here in colon, I say dot b, colon b, colon b. What do you mean by colon b? Well, colon means it is going to be a dotted line. Dotted line. Colon means it is going to be a dotted line, and b means blue color. Okay, and then I say over here that my label is going to be equal to cos of x. Well, you can use it in either in double quotes or single quotes. Python accepts everything, but if you are starting with double quotes, end with double quotes. If you are starting with single quotes, end with single quotes. Okay, and then I just have to say over here plt dot legend. Now just observe, what do you see? Hmm. Oh, I think I just missed out something. Oh, np dot sign, np dot cos. No, it's perfect. Oh, plt dot plot. My bad. Okay. So as you can see, I have also got a legend over here. That is the advantage of this. Are you all able to get this? Okay. This was quite few introduction to the basics of data science using NumPy and Matplotlib. In the next session, we are going to cover pandas and seaborn. At that time, as you all were expecting, we are going to read the data sets, do some operations, and let me tell you, your final project in data science is going to be purely based on the last two sessions, that is your NumPy, Matplotlib, Pandas, and Seaborn. Everything that you learn in the last two sessions will be required for making the project. And of course, basics are always required. It's not that basics will never be used. They are certainly used. Without understanding basics, you cannot go into the advanced models. So to some extent, basics will be required. But majorly, since the course is mainly focusing on data science, it is going to be on last two sessions. So that's it for today. Let me see if I get any questions. Do practice more. Do practice more. This was just a brief 30,000 feet high overview of all these modules. Okay. The detailed of this, we do cover it in our advanced program, not here because it's practically not possible since the length of this program is a bit shorter. Okay. Perfect. So we are good to stop. I don't see any questions. That's fantastic. Good. So is there any other way to use Jupyter Notebook other than Anaconda Navigator? Yes, you can certainly go to Google Colab. Google Colab is one more excellent platform, or you can go to Kaggle kernels. That is another platform. Okay, so I'll just write it down for you. Of course, I cannot tell you over here how, but you can always find it by Googling it out. Google Colab is one more platform where you do not need any installation, but yes, you need a stable internet connection. And the next is Kaggle kernel, where you can code, or you can also code in GitHub. Okay, these are the three places where you can do it without installing anything. From where do you come to know the attributes? I showed you last time, right? You come to know about the attributes when you visit the functions. If you go into the functions part, you will be able to see all of the attributes. Okay, just go to the documentation part of it. Everything is written over there. Love the session. Thank you very much, Arpit. Can you suggest resources to practice all of this? Well, the best resource is to go through the documentation part. In documentation, you have all of the examples listed. That's the best place to go through and get all the possible material. Perfect. So thank you very much, guys. See you all in the last session, where I'll be also discussing you about the project that we are going to go ahead with. So I'll stop my share now. Perfect. Thank you all. Thank you very much. Have a very good night. Happy Diwali. Anyways, we are going to meet just one day before Diwali. So I'll wish you at that time once again. So, yes. So thank you, Shoaib.
Thanks a lot, sir.
Bye-bye.
Guys, make sure you are submitting your assignments. Please don't wait till 16th of November. Please don't pile them up. Submit them ASAP on daily basis. We have received very less number of assignments, so make sure you submit the assignments before the deadline. 16 November, 12 midnight is the deadline. Make sure you submit it before that.